everyone. Today I'm here with a question. Is artificial intelligence a threat to humanity? Okay, so today is December 20th, and we have about 10 days left before 2017. And well, looking back, there's been a lot of things going on, right? There was a president scandal, Trump was elected, and there was a time when everyone around the world was playing Pokemon Go. The event that I want to focus on is when AlphaGo won against the world Go champion. So at that time, quite a lot of people were fascinated by this huge advancement of technology. But then there were people like Elon Musk or Stephen Hawking or Bill Gates who warned about the potential dangers of artificial intelligence. So is artificial intelligence a threat to humanity? Well, here's my thesis. AI, yes indeed, will bring about a lot of changes, but it is not an existential threat to humanity. So this is my basic outline. So first, I'm going to take a look at the common concerns that people have towards AI. And then I'm going to elaborate about why AI is not a threat, and then I'll move on to my conclusion. Okay, so first of all, these three aspects are the basic concerns that many people have towards AI. So first of all, job loss. According to a recent research done by Forrester in 2015, about 7% of jobs in the US will probably disappear due to AI by 2025. And yes, and then many other people are afraid of the advent of superintelligence and the misuse of AI. And these are quite well depicted in movies like Terminator or Transcendence. But in this presentation, I'm trying to focus on these two aspects of concern because job loss will happen over the next 20 or 30 years, but this is not really an existential threat to humanity. Okay, so now I want to talk about why AI is not a threat. While I was doing research, I realized that my topic itself is really subjective. So I read a lot of articles in MIT Tech Review, and there were a lot of scholars that would say that AI is a threat and AI is not a threat, but it's all their opinions because these technologies are not really in front of us right now. So we can't really objectively assess whether or not they're a threat. So I decided to take another approach, a slightly alternative approach by first proving to you that AI still has a long way to go. So we have a long time before its real arrival. And since we have a lot of time, we can prepare regulations. And therefore, in turn, we can prevent the dystopian future from happening. Okay, so as I said, I'm going to talk about why we have a long time before AI's true arrival. First of all, let's talk about some of the hardware limitations. Can you see the chart here? These are the hardware aspects of AlphaGo. And the part that I colored in yellow was its final version, which was used to compete against the world Go champion. And what I want for you to notice is that about 2,000 CPUs and 300 GPUs were used for computation. Now, you may not be so familiar with what CPUs and GPUs are, and since this is not a computer science class, I'm not going to elaborate on what they are. But I just want you to know the slight dimensions of them. So GPUs are approximately the size of a pencil case, and CPUs, the most recent CPU created by Intel is the size of a coin. Now, the reason why I'm telling you this is because I'm trying to make an estimation of how long it will take to have this whole AlphaGo system in our hands. And the reason why I'm doing this calculation is because if you think about it, like super intelligent machines, maybe like the ones that appear in Transcendence or Terminator, should have all of these integrated, all of this huge amount of hardware integrated into a very small amount of area. So since I've shown you that AlphaGo uses a lot of massive hardware around the world, it's quite meaningful to calculate the amount of time we need to actually have this huge amount of hardware integrated into maybe a size of a coin. So in order to do that, in order to make such a rough estimate, I'm going to use Moore's law. So Moore's law states that integrated circuits shrink half its original size every 1.5 years. Okay, so here's the calculations. So what I basically did is, you see, say this is the size of a GPU, okay? So maybe this was about 10 centimeters, and this is 27. And then here's a CPU, maybe its length and height is 2 by 2. And then what I just did is, from that chart I shown you, I calculated the total surface area, and adding them up, you get about 90,000. Okay. And as I said in Moore's law, the size shrinks every 1.5 years. So I took log 2 of this value, which gives us about 16 years, and then I multiply that by 2/3, and it gave me an estimate that we need at least about 25 years to make this whole system to shrink into a size of a coin. But the sad part is that Moore's law is projected to stop by year 2021 because of quantum mechanical issues. And I'm not going to get very deep into that, but yes, so definitely we may, in order to make this continuous shrink to happen, we need to have some other breakthrough technologies. And since we do not know whether or not those technologies would appear in the future, maybe the projected time would even get longer. And so what I've talked about until now is that software development is a lot faster than the hardware to accompany it. And actually there's another historical evidence of this. This person in the left, in the right, is Claude Shannon, who developed information theory around the 1940s. And information theory is this crucial theoretical basis for the modern communication systems. But as we all know, modern communication systems kickstarted around the 1990s. So you can notice that there's this 50-year gap between the theory and practice. And maybe for AI, I think the similar thing might happen, since nowadays a lot of fascinating algorithms are being developed by companies in Silicon Valley or by professors in Stanford, but still, I think there would be about a 30 or 40-year gap between theory and practice. Okay, so now I'm going to move on to the software limitations. So up until now, we made a projection that just by looking at plain hardware, we need 40 years. And I'm going to lengthen that time by elaborating the software shortcomings. So the basic question is deep learning really the ultimate algorithm? I'm pretty sure that you all heard about deep learning, right? Since it was used to create AlphaGo and the modern intelligent systems around 2010. So I researched some of the major shortcomings of deep learning. The first shortcoming is that it requires massive amount of data. So, for instance, to have a machine classify some CT images into 6 classes, we need to have about 200 data sets for training. And to have a machine play a successful game of Go, we need about 30 million moves for training. And this is a research done by Microsoft, and they found that the sufficient amount of data to have a machine distinguish human position, we need 50 million image frames. So you can see that this whole deep learning algorithm requires a huge amount of data. And this actually leads to all those hardware architectures that are necessary to realize modern AI. And this shortcoming leads to a secondary problem, which is that modern deep learning systems are prone to data pollution. And what I mean by data pollution is that because these deep learning systems are highly based on data, if the data itself is flawed, then the system could lead to error and bias. And these are the 2 examples. So first of all, the Microsoft, they're quite similar. Microsoft chatbot and IBM Watson. So both of them were exposed to slang words in Twitter and the Urban Dictionary. And then they started learning these bad concepts, and they started saying like sexual words and slang and so on. But although these are only chatbots, I'm pretty sure that other intelligent systems could also be prone to data pollution. Of course, and they're not really kickstarted now, so we are not sure what's going to happen. But still, I think it has a possibility. And the third and the last shortcoming that I would like to share is that deep learning perceives data superficially. So this is the basic architecture of a neural network. And what this is basically doing is these are modeling the neurons. So they take signals in the input layer, and then they start processing through a complex network of signals, and then the output layer would give out some results. But the thing is that this input layer just receives signals, and they're not really perceiving the object or the picture in depth. And this is a famous example given in IVPR 2016, which is a conference on computer vision. Scholars found that modern vision algorithms, which was basically on machine learning, they cannot really distinguish a bus and a bumblebee because they're just superficially receiving data by pixels, and since both of them are repetitions of yellow and black, they cannot really distinguish them. Okay, so these are the three problems. So we can conclude that even algorithm-wise, AI has a long way to go. So, so up until now, I've tried to persuade you that AI has a long time before its arrival. Okay, and so we definitely have a sufficient number of time to prepare for regulations. And as a matter of fact, companies around the world are already making regulations and doing research to create beneficial AI for mankind. For instance, Microsoft and Google DeepMind, they proposed a 100-year research in developing benevolent AI, and some companies will make partnerships to do a similar thing. Okay. So this AI is not a threat because, as I've used about 5 minutes or maybe 6 to prove that we have a long time, so we can prepare for regulation. So therefore, we can prevent the dystopian future. Okay. So in conclusion, I believe that AI would not take the form of those depicted in Terminator, but would rather be a decent or friendly companion of mankind, like C-3PO or R2-D2 in Star Wars. And I am quite confident that these intelligent systems will definitely make our lives a lot more convenient than before. Okay, and these are my references. Thank you.
So you showed that basically AI is probably not going to be a risk to us in our lifetimes.
That was my main point.
There was an interesting article the other day I read that showed that computers are already starting to talk to each other, or already capable of talking to each other, and encrypting their communication, and developing their own communication, and then locking humans out.
Really?
Yeah, so that was pretty interesting and scary. And I thought that even if they're not alive, even if they don't have a will or feelings or desires, they could still unleash a kind of virus intelligence that could kind of screw things up for humanity.
Well, I really never heard of that, but well, I guess those intelligent networks really not appear in the near future.
Check the Independent. I think it was in the Independent. They're publishing all kinds of interesting and poor quality stuff mixed together at the moment. Yeah, the other thing was that you answered the question that AI, you asked the question, is AI a threat to humanity?
Yes.
And your answer was not yet. Well, your answer was no, but actually the answer was not yet.
Sort of like not yet, and we are preparing for regulations.
But I mean, I've never seen any students do it, but when I was a philosophy undergraduate, we had to answer the question about whether it's ever going to be possible that for an AI to actually think or to be alive. And so we looked at the Turing test, and we looked at the Chinese room experiment, and we looked at all that kind of thing. I think that's really important to answer. You know, is there ever going to be an alive AI? You know, like Short Circuit or Chappie. You know, is it ever going to be possible for an AI to be a kind of life form or an entity? I think if we answer that question, we'll know if AI is going to be dangerous or not, right?
But you know, that question is rather quite philosophical. And
yeah, but I think it's possible to answer it using.
Really?
the resources that are out there.
Because but since my major is related to engineering, I sort of wanted to take a more technical point of view and try to take the perspective that, because it's quite hard to prove that something is impossible to make, right? And if you think about it, maybe like 30 years ago, people even thought that it's impossible to make machines that play Go, because Go has so many possible moves that it's impossible to compute that within any given amount of time.
Yeah, and so they didn't anticipate deep learning, which is a self-learning system, right?
Yes, and actually in the 1980s to the 2000s, there was this dark age in AI because people didn't really think that it's going to work, but then now it's repowered by these powerful algorithms. So yes, actually.